Now we'll take a look at the 1000BASE-T1 protocol decoder with a demonstration. First, we'll go into the channel menu and go to the probe settings. Here we have to enable an external scaling factor to account for the coupler that's in the path. So all you have to do is set that to -11 dB. If you were probing with 2 channels connected directly via cables, you would have to do this on each of those channels, but we're just doing it on our probe amp here in this example. Once that's set, we'll go to the protocol decode setup, and you can see now there's an Automotive Ethernet 1000BASE-T1 option. So we will do an auto setup here, and we'll stop the acquisition. And what you see here is that it has decoded this yellow bar below the waveform, and then there are this the symbol list here underneath the waveform. So that means that our decoder was successful recovering symbols, and we basically have no further steps to take initially here. Now, sometimes this doesn't happen, you won't get this symbol lister, and what you can do is check this box that says receive polarity reversed, and this can account for the link initializing in a reversed polarity mode. So that's an easy way to troubleshoot maybe the first problem you can come across. You can also go into the manual setup here and observe what was set in terms of the symbol thresholds as well as the clock data recovery settings. But all of this is just pushed automatically by the auto setup feature. So what you'll notice is we do not have any packets here yet, and that's because this is all just idle traffic. But what I'm going to do next is enable an FTP file transfer over the link so that we can see IPv4 packets. And I'm going to have to change the trigger here from protocol to edge because the protocol trigger at this time is still under development. So I'll take another single capture here, and hopefully we see some packets. Okay, so we did get a couple of packets in this capture. What you'll see now is probably pretty familiar to you, that on the far left side we have chronological listing of the packets that were captured, and each column has got some additional information. So as you can see, this is these are 2 good IPv4 packets, and again, as should be pretty familiar, on the far right side we have this details listing sharing all the information about these packets that we might want to know. The header view shows us something a bit more like the data sheet or the specification might show for an Ethernet standard. It's kind of a nice quick way to pick out specific fields whose location you already know. This is an easy way to pick out these single bit values, for example, inside the header view. Then of course there's a payload view as well. So this is the data that was being sent over the FTP transfer. Something that's new in the 1000BASE-T1 decoder is this slightly more verbose symbol output. So instead of just the numerical values of the symbols, we actually see indications of the start and stop of header information, of control block information, of data block information. We see FEC parity indication. We can also find things like OAM symbols. So to the point of looking for things, the protocol search feature is back for 1000BASE-T1 as well. So if we enable that, the drop-down shows us some familiar Ethernet packets we can search for. And it also now shows us this symbol sequence option. So if we choose that, and then we click into the field option here, we can change the selection to K code and start to look for this selection of these symbol values that we see reflected in that symbol listing down below in green and white. So for example, we saw some header control blocks, and we'll try to search through those. So we'll wait for the wheel up here in the upper right to stop spinning, and then we'll know that it's done its search. So that's done. And now we can begin navigating to these header control blocks. And of course, we see the symbol highlighted in the lister, and it's going to jump to the relevant piece of the waveform as well. So this is a really powerful way to navigate around to not just high-level packet information, but symbol-level information as well. So this is a nice debug tool built right into the 1000BASE-T1 decoder. Next, what I'd like to do is a default setup. And I've taken a previous capture on a different device under test and saved it. So I'm going to load that into waveform memory. And we'll put it on memory 2. We'll tie that to the time base. And just like live data, we can then go into the protocol decoder, choose our standard, point it to the memory, and do an auto setup. So here we see no symbols. Well, it's actually still thinking. In the event that we don't see symbols, what I'll do is check this receive polarity reversed, because it might happen that the waveform we saved, that was the case on the link. So as it's still thinking here, I'm going to go ahead and check to reverse the polarity. And that was the problem. So with relatively short records like this, they decode pretty quickly. So if the wheel keeps spinning, there's a good chance that it's working in vain, and we have to reverse the polarity, and that ends up doing the trick. So here we see in this column of the packet lister, we've got this column called FEC. So 1000BASE-T1 uses a forward error correction algorithm, and that algorithm is capable of correcting certain types of errors. And when the decoder detects those types of errors, you might have noticed in the setup window that it automatically was set to correct the Reed-Solomon FEC errors. So those, if they are correctable, then show up as good packets here, as packets without error. And you can see it's indicated that all of these have been corrected. So that means when they were captured, that they were captured with checksum and CRC errors in them. But as we scroll over here, both of those fields are calculated as good for all of these packets. So what we should see when we disable the correction of these errors are a bunch of red packets in our lister. And we see exactly what we expect. The actual CRC and checksum values are not consistent with the values that were computed according to the algorithm. So this means, of course, that these would show up as symbol errors in something that wasn't capable of correcting FEC errors. But because this is part of the standard, now we can indicate which of these errors would be handled by the Ethernet receiver. So this is another really interesting and powerful new feature of the 1000BASE-T1 decoder.